Hello, welcome to the third episode in the Minecraft clone tutorial series. Today we are going to be drawing our first triangle as well as some other organization and stuff. So let's go ahead and get into it. So in the last tutorial I made an error. I created two constants, a screen width and a screen height, but this doesn't make any sense because we're going to be changing the width and the height every time we resize our screen. So I went ahead and changed these into just regular variables into width and height and then assign them like so. So you want to go ahead and change this. And yeah, that should be it for that. There's another thing, just a little note. The reason we're using here is a little C# feature. Whenever we create the game object here, within this scope is whenever this game object is being used. So we're only going to use it within this scope. And then after this, the object is disposed of. So this is just a nice little way of telling C# when it can dispose of this object here. So let's go in here and let's set up our basic game structure before we get into how to render stuff with OpenTK and OpenGL. So there are a couple methods that we inherit from game window here, and we can override these to add our own functionality to them. So the way we do that is we create some override methods, and there are a couple ones that are useful to us right now. The first one is protected override void on load. And if you press tab on Visual Studio, it should autofill this. If you're not using Visual Studio and you don't have this IntelliSense, good luck to you. It's very, very handy in this process. But we have this protected void on load here, and it calls the super method based on load. This method is called once at the beginning when you first load up your game. Then we have another one that we need. We're going to do protected override on unload. And this, you can probably imagine, this one is called whenever the game is closed. It's called once, and it unloads everything. And then we need the protected override void, and then on render frame. This method is called every single frame, and it is used for all of our rendering, all of our drawing onto the screen itself. This is called every single frame, and also calls our super method here. And then we have another one. We're going to do protected override void on update frame, and this is also called every single frame and is used for all of our updating. And you might ask yourself, why do we have two methods that are called every single frame? What's the point? Why not just make it into one method? There's a couple reasons for this, and most of it is readability and good structure. Most game frameworks do separate the rendering from the updating, or at least they strongly suggest you to do so. This is just for good practice reasons. As a game programmer, you should be separating your rendering from your updating in most situations. So now there's one more method that we need to add, and this is relevant to our resizing. So here I'm going to do protected override void on resize, and I'm putting it up here just because it's relevant to the width and the height. It does not matter what order you put these. This is just the order that I'm doing it. And this on resize is called every single time you resize the screen. And we want to do a couple things here. So the first thing we're going to do is we're going to actually resize our OpenGL viewport. And for this, I'm going to have to explain how OpenGL works. And first off, OpenGL is what OpenTK actually uses. OpenTK is simply a set of C# bindings for OpenGL. So whenever you're using OpenTK, you are really using OpenGL through kind of like the lens of a C# program, kind of. So whenever I'm talking about OpenGL, that's what I'm talking about. So basically, we have to resize our OpenGL viewport because when we resize our OpenTK window, OpenGL does not know that we actually resized our screen, and so we have to tell it to resize itself. And this OpenGL screen, its viewport, is where it actually draws everything on the screen, and then we take that screen and we apply it onto our OpenTK window. So let's go ahead and resize the screen. So what you do is you call gl.viewport, and this takes in 4 arguments. And it's a box 2i box, if you can read down here. The first 2 arguments are the X and Y position, and the second 2 are the width and the height. Since we want our screen to fill up the entire window, we're going to do 0 and 0. And then for the width and the height, we're going to do e.width and e.height. And this e.width and e.height are provided by the resize event arguments that we receive when this method is called. And we want to do one more thing. We're going to do this.width equals e.width, and this.height equals e.height. This is because we're going to be using the width and the height later on in this program, and so it's good to make sure that our width and our height up here are accurate. All right, so now we have this proper resize, but you're not going to see anything if you run your program. So we're going to create a simple little thing inside of this onRender frame to actually fill our screen with color, and then we will get on to drawing the triangle. So what we're going to do is we're going to do gl.clear color, gl.clear color, and this is going to receive a color. And it receives 4 numbers, and this is an RGB code. So we're going to do, I'm going to do like a little light blue, hopefully, maybe, we'll see. So maybe this is, it takes 4 floats that are from 0 to 1. So I'm going to do like 0.6, 0.3, and then 1.0 or 1F, and then 1F for the alpha value. The alpha value is just simply how opaque it is. And now that we've set up the color, you're not going to actually see anything. This is a common thing that happens with OpenGL. OpenGL has a structure where you set up things and then you apply them after you set them up. And this is a common pattern with OpenGL. So now that we've set up our color for our clear color, we actually have to apply it. So we're going to do gl.clear. And then we're going to do clear buffer mask .color buffer bit. I'll get into more in depth of what this actually means later on in the tutorial, but for now, just know that's what you do. And then we have to do one more thing. We do context dot swap buffers, and this swaps our OpenGL buffers because OpenGL works with 2 windows: the window that it's currently drawing on and the window that is displayed. And then every frame it flips those and then draws onto the old window and displays the new window. So now that we have all that, if we run this and it doesn't blow up, we have definitely not a blue, but we have a window, and when you resize it, the color fills it. So now that we're done with our prerequisites, we're going to go ahead and get into drawing the actual triangle. So for this, I have a couple little visuals here. This is the OpenGL render pipeline in its absolute simplest form. So what we have here is we have the data that we create in the CPU through our code, and this data is put onto VBOs. And so let's go ahead and walk through this entire thing. So VBOs are what are called vertex buffer objects, and these vertex buffer objects are going to contain our data. And this data can be anything from vertex data to texture data to color data. All of these things like that are going to be stored on VBOs. And these VBOs are going to be sent to the VAO, also known as the vertex array object. The vertex array object is simply this object here that has different slots, and these slots correspond to the particular data. And there is no special order for vertex data first, texture data first. It doesn't matter. You just have to know, you have to put it in a slot and know where that slot is. So in this example, I'm putting vertex data in the slot 0 of the VAO and texture data in the slot 1 of the VAO. This VAO then is sent to the shader program, which has at the minimum a vertex shader and a fragment shader. The vertex shader is the one that receives the data itself from the VAO, and inside of the code that you will write for your vertex shader, you will have the different slots. You will receive the different slots and then tell it what to do with those slots. So at location 0, you would specify location 0 is the vertex data and do this with the vertex data. Location 1 is the texture data, do this with the texture data, and I will show you how to do that very shortly. So yeah, now with this, we have to go into what do these shaders actually do. So in this shader program here, we have our 2 simple shaders here. The vertex shader is the one that actually specifies where our vertices are going to be placed. It takes in the vertices one at a time, and it places them at this specific location that you specify in your actual vertex shader. The fragment shader comes next and doesn't care about the position at all. It only cares about what color is displayed at each vertice, and this is what actually colorizes your screen. So after it goes through this whole process, you should see a proper triangle if all goes well. Now this is a very long process, especially when you're first starting out, so it can be very intimidating, but if you keep at it, you know, more repetition, eventually you'll get this down and it'll be no problem for you to go through this entire render pipeline. So that being said, let's go ahead and create a simple triangle using this render pipeline. So like I said, this is going to be a very much longer tutorial, but go ahead and bear with me and we'll get through this. So here I'm going to create a couple things. I'm going to create first I'm just going to create a simple array of vertices. And for this we have to talk about how OpenGL coordinate system works. So I actually didn't create a graphic for this, unfortunately. I just realized that I should have. But basically, imagine this is your screen. The absolute center point of your screen here is going to be 0, 0. So if you put here, this is going to be 0, 0. And then the top right is going to be 1, 1. And the top left is going to be -1, -1. And the bottom left is -1, actually -1, +1, my apologies. And then 1, -1. So this is literally just like a standard coordinate plane. And this is really good for 3D calculations. That's one of the big reasons why they do it this way. Because you can just think of this like a regular coordinate plane. That is the least straight arrow I've ever made in my life. But basically, imagine this like your simple coordinate plane you learn in algebra with your different quadrants, and this is kind of how it works. So now with that being said, let's create a triangle that's like roughly 1/2 the width and 1/2 the height of our screen. So for that, we're going to create an array. And I'm going to call this, I'm going to create a float array. I'm going to call this vertices equals a new float. And this is going to contain 9 vertices. So we're going to create a one of length 9, and then we'll do vertices equals, whoops. Actually, we're going to do it this way. We're going to create it like this. And this is basically saying that it is whatever length of whatever we put this data in. So let's go ahead and put in our vertices, and it's going to take in an X and a Y and a Z for each vertice. Even though we're only going to be creating a 2D triangle for this tutorial, it's going to take in a Z, but we're just not going to we are going to ignore it for now. Sorry about the stuttering. So we want the X position for this. For the top one, I'm going to just put 0, since we want this to just be in the center. And then I'm going to put for the Y position, I'm going to put 0.5f, and then for the Z, I'm just going to put 0f. And then I'm going to do for the bottom left corner, we're going to do -0.5f, and then for the Y, -0.5f, and then 0f. And then for the bottom right, we're going to do 0.5f, -0.5f, and 0f. So this is the top vertex, bottom left vertex, and bottom right vertex. All right, so now with that in place, let's go ahead and use this data to create our triangle. And there's going to be a lot of setup for this, so bear with me. All right, let's get into it. So let's go ahead and get this going. So for this, we're going to have to declare some instance variables. This is for our render pipeline, so I'm going to create a little comment called render pipeline variables. Let's also spell correctly. And I'm going to want a VAO. I'm going to call it VAO, and I'm going to want a shader program. These need to be global for particular reasons we'll get into later. All right, so let's create our VAO that we're actually going to be storing our data onto. So the way we do that is we do VAO on our onload method, VAO equals gl.genVertexArray. That's all it takes, and we're all done with creating our vertex array object. Now we need to actually put some data into this VAO because this is just an empty VAO. So let's go ahead and create a buffer and put some data in it, and then use that buffer to put data into our VAO. So for that, we're going to do int VBO equals gl.genBuffer, and this generates our VBO buffer. So now we are going to go ahead and use this to add our data. So for this, we're going to do gl.bindBuffer, And this takes in two arguments. This is going to be buffer target.array buffer and VBO. Let's talk about what this is doing. So whenever we're calling bind buffer, we need to actually bind the VBO that we want to our current OpenGL context. And OpenGL is a little bit weird where you don't actually use these values themselves, these variables, to do things like bind them and add data to them. You use what's known as the OpenGL context, and the OpenGL context kind of stores, has things bound to it. So for example, since this is bound to our current context, everything that we do relating to a VBO of type array buffer is going to be referencing this VBO that we have right here until we decide to unbind it and maybe bind a new one. Then that new one will be the one that we are using whenever we use things like bind buffer or buffer data into it. It's a little bit confusing, but as you go along, you start to understand this. So for example, like let's say we have, let's do gl.bind buffer, and then we do buffer target.array buffer, and then 0. This is for unbinding VBO, unbinding VBO here. So basically, between these two is wherever VBO is going to be used. This is whenever, if I do anything between these two, this VBO here is going to be the one that we are referencing if we use it. That and if I were to create a second variable called VBO2 right here, and then I were to bind it here, then everything between this will be referencing VBO2, and everything between this will be referencing VBO. That's a kind of simple, sort of accurate explanation, but that's basically how this works. So now let's go ahead and actually put data into this VBO, because currently we have bound it to the context, but we have nothing inside of it. So let's actually put some data inside of it called gl.buffer_data. And this takes a target. So we're targeting the currently bound array buffer. And then it takes more arguments, not that. It takes the size of this, and for this we're going to actually do the length of our vertices of array, vertices.length, and we're going to multiply this by the size of a float. And the reason we do this is because we're actually wanting the actual size of it in memory. And then the next thing we need is the data itself. So we're going to send vertices. And then we need a how we're going to use this. So we are going to use buffer usage hint.static draw, which is basically, if we want to draw this every single frame, we'll use buffer usage hint.static draw. All right, so now we actually have data inside of our VBO. So what are we going to do with this data now? So we have to put this onto our VAO. And the way we do that is we have to first bind our VAO to the current context, because remember, it only works with whatever is bound to the context. And right now we have no VAO bound to the context. So we are going to bind the VAO, and we're going to do gl.bind vertex array. And this only takes the variable itself. And this is because there's only one type of VAO, the vertex array object, so we only need to put this VAO. We don't need to specify whatever the target is for it. So now the VAO is bound. Now we need to actually put the data into our VAO. And the way we do that is we use this method called gl.vertex attrib pointer. And this takes in the slot on your VAO that you want to put it. Remember the slots that I was talking about here, where there's different slots in the VAO? It takes the slot that we want to put it in. So I'm going to put it in at 0, because why not? It's the first one. And then we need the actual size of our data. And this is not to be confused with the size of the entire data. It's the size of the actual data per vertex. And since we have 3 floats per vertex for the X, Y, and Z, we are going to put 3 here. And then we need the type, which is vertex attrib type.float, which is the type of data we're sending it. Normalized, I'm going to put false. Stride 0, offset 0. The stride is basically saying, let's say that we had color also here. We had like color 2F, 3F. The stride would basically every loop here, it would skip over 2. So if we had 2 numbers here on every single one of these, it would skip over these 2. That's what a stride is. It's kind of skipping over data. If you want to compile like multiple data into one array, that's what you would do. But since we only have our vertice data in that float array, we're having a stride of 0, and the offset is simply where does it start. So if we put an offset of 1 here, it would skip over the first element inside of our array, but we don't want that, so we're going to do 0. All right, and now we need to actually enable this slot because the slots on the VAO by default are not enabled, so we have to do gl.enable vertex attrib, and then we put the slot number, which is 0. So now it should actually, we put the VAO we are targeting, and then we put the slot number. This is saying in the VAO that we called VAO, we are enabling slot 0. All right, and now some good practice things. Unbind your VBO like we did before, and also unbind the VAO. So gl.bind vertex array 0. This simply means unbind the VAO. Now we need a couple more things, and this is where it can get a little bit difficult. We are going to need a way to actually read our shader code, because shader code is not written in C#. Your GPU does not understand C#. So we need to write in a language known as GLSL, and this is used for your GPU to interpret the data that it gets from the VAO and draw the proper stuff. So for this, I have a method that I've already created, and this is simply a method to read from a file and process the data. You can absolutely learn every ins and outs of this, but since this is a OpenTK tutorial and not a file IO tutorial, I'm not going to really talk about what this does, but here I'm going to just paste this little method here. And basically this is a load shader source, so it takes in the file name of your shader, and then it reads everything inside of it and returns it as a string. And so this is up on GitHub, by the way, so you can go ahead and just copy and paste it from there. But yeah, that's all it does. And so you'll see that this is actually trying to take it from a shaders folder, but we don't have a shaders folder. So let's go ahead and create a shaders folder. So let's go up to our project here, and we'll right click, add new folder, call it shaders. And now we have a shaders folder, and then right click, add new item, and we're going to make 2 new things. So we are going to do default.vert, and we're going to add new item default.frag. And this is going to be the vertex shader and the fragment shader respectively. I'm calling them default because it's like just the standard ones. So we might have some fancier ones later down the line, but these are going to be our defaults. And now I have code for both of these, and I'm going to go ahead and just copy them and paste them in, and then explain what they all do. So here, let's go ahead and we need to specify the version 330 core, and then we need to actually tell the GPU what the data in each slot means. So for this, we're going to do layout location equals 0 in vec3 a position, and this is our vertex code. And by the way, you can add comments. So this is our vertex coordinate. Okay, and now let's go ahead and use this inside of this vertex shader. So for this, we're going to create a main method here. We're going to do, or a main function, void main. And yeah, there is no autocorrection here, so you're kind of on your own for this. So mistakes are absolutely very much an issue with this, where you can completely mess up and not realize for a million years. But basically, we want to call this GL position, and it does have to be GL position in this context here. So we're going to do void main GL position, and I'm going to zoom in a little bit. Sorry about that. Equals vec4. Then we want the a position, and 1.0. And this is our coordinates, just our coordinates processed. And then that's all we have for our vertex shader. So now we're going to go into our fragment shader, and we're going to do the same thing. We're going to specify the version 330 core. We don't need to tell it the layouts here. It gets that from the vert. And since we just want a flat color for now. That's all we have time for in this tutorial. So here we're just going to do void main And then we're going to do, I believe it is frag color equals, and then we need vec4, and then let's just specify, let's make it a red. I'm gonna make it a red. You can make it whatever you want. 0.0, 0.0, 1.0. And I do not remember if it is F or not F. So let's go ahead and test it without F and see if that works. But now we need to do an out, which basically means that we are sending this data to our GPU. So we're going to do out vec for frag color. This is basically saying that we're going to process this here, and then we're going to send it out here. And since it's just a flat red, it's going to be a flat red output for all of our vertices. So now we have these two files. They both have all their stuff in them. Let's go ahead and add this into our game. All right, let's get into it. So there is a bit more code we have to do here, but we're in the home stretch. We are almost there, even though it doesn't seem like it. We are almost there. Let's go ahead and create the shader program. For this, we're going to do shader program equals gl.create program. And this creates the shader program. And now we need to create the vertex shader and the fragment shader. So for this, we're going to do int vertex shader equals gl.create shader. And then we need the type of shader. So shader type.vertex shader. And let's go ahead and also create our fragment shader. Int fragment shader equals gl.create shader. And this one is the shader type.fragment shader. And now for each of these, we have to do some more setup. So for this, we're going to have to do gl.shader source. And this takes in the shader itself, which is the vertex shader we're referencing. And then we need the actual string value of our vertex shader. And the way we do that is we use that method that I imported before. So I'm going to do load shader source. And then in here, we need the file name. So I'm going to do default.vert. And if this doesn't work, play around with the file path being used here. For me, it seems like I have to go back 3 files and then go into shaders, and this works every time I make a new project. But go ahead and play around with that if that's not working. And then we have to do one more thing. We have to do gl.compile the shader. We have to compile the shader itself, and this takes in the shader, and that's it. And let's go ahead and do the exact same thing for our fragment shader, making sure to change vertex shader to fragment shader, as well as the string here to default.frag. All right, we have created the shader program. We have created the vertex shader and fragment shader, added the sources and compiled them. We now have to actually put these inside of our program. So let's do that by attaching them here. gl.attach shader. And we need the actual program, which is the shader program. And then we're attaching the vertex shader. And let's do the exact same thing for the fragment shader. Fragment shader, boom, boom, boom. All right, now that we have these attached, we actually need to link the program to OpenGL. So we're going to do gl.link program and link the shader program. And then the final step is a recommended step, not required, but you should do it. We're going to delete the shaders here. So we're going to do gl.delete shader, and we need the vertex shader. And then we need to gl.delete shader and the fragment shader. And don't do that. Okay, now we are officially done with the setup. Let's get some actual unloading done and then some drawing done. So lastly, what we need to do before we can actually do the drawing code is we need to delete everything that we don't need in the unload method. This is just for memory purposes, we need to go ahead and do this. So let's go ahead and do delete buffer, and this is going to take in the buffer. I actually can't do that because it's not public, so let's go ahead and avoid that for now. Let's do gl.delete vertex array, and then we will say VAO. And that will delete the VAO, and then we need to do gl.delete program and the shader program. And it's okay if we don't delete this. This is just good practice. I'm teaching you good practice so you have it in your brain from the get-go. But yeah, you want to go ahead and delete things whenever you're not using, whenever you're done with them forever. So there you go. Now we need to actually do the drawing. So for this, we're going to go into our onRender frame, because remember our onRender frame method is for all of our drawing. So let's go ahead and go between where we are drawing the color and swapping the buffers, and let's go ahead and draw our triangle. So for this, we're going to have to do a couple of things. We're going to actually have to use our shader program, because right now we have it, but we haven't used it. So we're going to do gl.useProgram, and we're going to call the shader program. So we're using the shader program. Now we need to use the VAO that we want. So gl.bind vertex array, VAO. This binds it to our current context so that OpenGL uses it. And then we need to actually draw it. So we're going to do gl.drawArrays. And this is going to take the primitive type mode, and we want triangles. And this is because everything is rendered in triangles in 3D, but we'll get more into that in the next video. Then we need the first element, which is 0, and then we need the last element, which is 3. And this is because we're drawing 3 vertices. And now that I'm fully out of breath, we can render this and cross our fingers that nothing was wrong, because that was like 100 lines of code straight. So let's go. Oh, let's go. I'm insane. Okay, we got our red triangle first try using the render pipeline. So there you go. That was only 30 minutes. So I consider that a pretty good feat. Anyways, this is pretty cool. You can go ahead and play around some things. I recommend playing around with a lot of stuff here. You can go ahead and go into your fragment GLSL code here and just mess around with some stuff here. So I'm going to make it green instead, and you'll see that it'll come out green. I mean, it's pretty cool. It's pretty cool. And you can also do a lot of things, but we will get more into how to actually use these shaders properly in future tutorials. But for now, we've got something drawing. It might have taken the entire year, but we've got it working. So thank you very much for watching. If you have any questions, let me know. If you have any criticism, let me know. I appreciate it all. The code is on GitHub. It's going to have comments on every single thing. And I recommend going through that and studying and making sure you understand, so in the future tutorials, you have a better foundation to stand on. With that, thank you very much. Have a great day. See ya. Bye, guys.